Good morning. I'm Jennifer Schenker, founder and editor-in-chief of the Innovator, a global publication that connects business with technology. And it's my pleasure to welcome you to Cracking Compute, Deep Tech's role in the AI chip revolution. We have with us here today Seth Bannon, from 50 years, a Silicon Valley venture firm that invests in deep tech companies that help change the world. That's not exactly right, but
we'll take it.
I'll let him use his tagline later. And we have Dennis Michaelis from GEMESYS, and Sumeet Kumar from Innatera, two companies that specialize in neuromorphic computing. So I'm just going to take a second here to set the scene before we get into our discussion. When we talk about AI chips, we can't not talk about NVIDIA. By some estimates, it controls 90% of the market for specialized chips used to build AI systems. And it's had a remarkable run since OpenAI released ChatGPT in late 2022. DeepSeek's release challenged a tech industry consensus that in order to build bigger and better AI systems, companies would have to spend billions and billions of dollars on new data centers. At the center of those data centers would be the one thing that perhaps until now no AI project could do without: a large cache of NVIDIA's chips. But that may soon no longer be true. This panel will look at how the AI chip market is evolving. The neural networks that have powered recent progress in AI are loosely inspired by the brain, demonstrating the potential of technology that takes its cue from biology. But the similarities are only skin deep, and the algorithms and hardware behind today's AI operate in fundamentally different ways to biological neurons. Tech entrepreneurs hope that by designing technology that more faithfully replicates the way the brain works, they will be able to mimic both its incredible computing power and its energy efficiency. In this panel, we'll look at how neuromorphic computing and other ongoing rapid advances in the AI chips game will transform the future of deep tech. So let's dive right in. How are newer players innovating in the AI chip value chain, and where can startups have the biggest impact? Let me ask you first, Seth.
Sure, yeah, thank you. Well, I would say there's more places startups can innovate than not. Maybe at a very high level, the conversation around chips has mainly been focused on training, right? So training is the making of AI. Inference you can think about as the using of AI. And over the next decade, there's going to be a lot more using of AI. Inference probably already accounts for over 50% of the compute in AI. It's hard to tell for sure, but over the next decade, that could easily go to 10, 100, 1,000x the amount of compute used for inference versus used for training. Now, NVIDIA is doing very well in training. I think they probably will for a long time. Right now, they're clearly the leader in inference. But if you think about how many very specific, very important applications there are in the using of AI, there's a huge opportunity for very specialized chips. So if you take just one application, humanoid robots, which right now aren't really a thing, but I think probably in the next decade will be everywhere. In your typical humanoid robot right now, you might have two chips dedicated to some sort of AI compute. You might have a CPU, and you almost certainly have a GPU, probably an NVIDIA Jetson. But if you think about how that might look when humanoid robots are scaled, we might have a lot more specialized chips for particular functionality we want in these humanoid robots. And so just a few chips that we might have that are specialized for AI compute. We might have a vision and sensor fusion chip, which helps take inputs from camera, LiDAR, ultrasound, and make sense of all that in real time. We might have motor control specific chips focused on managing gait and balance and driving dozens of actuators. We might have a conversational, natural language processing chip. This This might look a lot like, Apple's neural engine chip focused just on language. We might have an emotional intelligence and human interaction chip focused on understanding facial expressions and tones and human gesticulations. We might have a neuromorphic chip, which focuses on energy-efficient, long-term learning. And we might have an extremely low-power chip for some sort of ambient sensing so that the robot can constantly know what's happening in case it needs to sort of wake up. And by the way, we might need all those chips with a power budget of like 10 to 20 watts. So this is technology that almost certainly needs to exist. Basically, none of those chips right now exist with the functionality that they need to have. And yes, NVIDIA will try and make some of that, but I can guarantee you they're not going to make all of it. And that's just, by the way, those are chips for just a single application of AI. So I think there's just massive opportunities for startups.
Thanks, Seth. And I think it's worth noting, even though we're not there yet, people don't have robots in their home, it may not be so far away. And just this morning, Google DeepMind announced Gemini, a new program, a new AI brain-like approach to robotics that will make robots more flexible and be able to perform the kind of tasks we would need them to do someday in the home. So it may not be here yet, but it's coming, and it's a good area to focus on.
And I think people will be shocked at how quickly robots make it into the home.
Thanks. Okay, so now let me turn to you, Dennis. Let's talk about where you see the opportunity and what you're focusing on right now.
Yeah, sure, absolutely. So I think there's a great place for startups to be in the AI chip field at the moment, because right now we're focusing on data center exclusively. And so that means that's dominated by NVIDIA. But as we saw the same trend with already in the computer, so you had computers in research institute like these very big machines. Then there came the revolution with the personal computers. Then these became more mobile with laptops. And in the end, now we have our smartphones. So it became portable, became distributed. And I see the same trend going on. And NVIDIA is dominating that data center market. But there's a lot to be gained on edge devices like on-device inferencing, even on-device training. That's something that we at GEMESYS are working on. And I think there's a lot to be gained here, because if you compare it to the human brain, which is of course the template for AI, the best chip on the market is 1 million times more inefficient than the human brain. So there's a lot of stuff just to be gained at the hardware, and that doesn't even include like all the innovations that could be done in a software level stack. And yeah, that's a great place for a startup to be in, because like real innovation is hard for these big companies. They have their strength actually when you want to produce chips at scale, and you need to have some runtimes at TSMC, then it's of course great. But to do the real innovation, to come up with fundamentally new architectures, which is something that Innatera and we and others are trying to do, that's the great place to be.
Okay, Sumeet, let me turn to you now. You're also working on neuromorphic computing. Your company is a spin-out from Delft University in the Netherlands. Talk a little bit about your approach and where you see the opportunities.
Sure. So I think when we look at AI semiconductors, there tends to be an overemphasis on NVIDIA. And when you look at the broader ecosystem of where we can apply AI, there are so many opportunities. And I think the key point is to look at the big picture and see where AI can go in and make a difference. This is going to require really new architectures. So what we focus on at Innatera is on building intelligence for sensors. So what we do is we take brain-like intelligence, back them into tiny chips, which are 10,000 times more efficient than anything on the market today. And we deliver intelligence into sensors that consume less than 1 milliwatt of power. All of this is going to require fundamentally new architectures, fundamentally new approaches to computing, and that's going to unlock so many more use cases. And I think that that's the biggest bucket of opportunities that startups have got. But we've also got to think about, we've got to think out of the box. It's more than semiconductors alone. We've got to think about the software ecosystem. You need better software tools to support all of these new processing approaches which are coming out. You need enabling technologies. Think about interconnects. How are you going to connect all of these AI accelerators together? New memory technologies that can support the greater bandwidth and the memory throughput that these accelerators are going to require. Power management techniques. There are so many little blocks in that entire value chain that nobody's thinking about. And I think that that's the key for disruptive startups to come out and establish a space for themselves on the market, sometimes without any competition.
Thank you. Now, before we go into some of the specific applications for AI chips going forward, I'd like to ask the audience if you want to ask questions to please use the QR code that's going to be put up on the screen and send your questions in, and we will do our best to get to them. Thank you. So now let's look at the impact. Seth, in the run-up to this, we talked about Apple's vision for the future. If everyone is going to have, AI on their phone, what does that world look like, and what new opportunities does that open up?
Yeah, and so just in case anyone's not familiar, Apple has made a big bet that the future of AI use is going to be on the edge, on your device. It's going to be a model that runs locally, maybe with no data sent back and forth between your device and the cloud. And I think we're at a really exciting turning point right now, where we're shifting from sort of this massive cloud data center powered ecosystem towards AI literally right in our pockets. And if you consider this, obviously this is an Android, not an iPhone, but the latest iPhones have 16 core neural engines that are capable of running, performing 35 trillion operations per second. And so that, they are investing heavily to pack incredibly powerful chips into their phones, specifically for this use case. Why is this important? It's important because it enables AI tasks like generating images or analyzing videos, processing natural language, all the things you might do with these online models, but without your data ever, literally in this case, leaving your hands. They're extending this with a sort of private cloud compute where they split, where some things are performed right on device, some things that might need to be done in the cloud are sent to their sort of private cloud. And this is really interesting because it means now that we might have models that can either be trained or fine-tuned on your data, on your healthcare data, on your emails, on your texts, on all of your photos of you and your family, but in a way where that doesn't cause heartburn because no one is seeing that data. It literally doesn't leave your phone. And so that might enable a future of personalized AI that's just simply not possible if everything has to go to the cloud. And so, to make this possible, we're now packing what used to require an entire room, an entire data center, into a phone, right? And, you talked a little bit about this. And by the way, it needs to work and then not melt the device, which is really not easily. And so it's entirely plausible that in 5 years, your smartphone or literally your AI glasses might have the same performance of today's sort of data center-based compute infrastructure. And this is a huge opportunity of innovation for startups because we need a lot of specialized chips on the edge, as was mentioned, to make this work. And so the future might look like AI everywhere, where it's very, very decentralized in a big way and integrated into all of our devices. In 5 to 10 years, it's possible that we look back on this age of having sent all of our data into the cloud and kind of think that was like a little bit foolish.
Sumeet, your company is working on ways for personal devices like Fitbit or watch or whatever to be able to continuously process personal data without leaving the device. So can you talk a little bit about that and your vision of where you see this going?
By the way, we're not investors. This wasn't a setup. Just believe what I said.
You're welcome to invest if you want to. So when we started Innatera, the key problem that we saw was that AI was really being done in data centers. And if you've got to have an intelligent environment around you, AI will need to be done practically everywhere. Think about this. Every time you do a voice search or you talk to your Alexa device at home, do you think about how much energy that consumes? Do you think about how much energy is spent in the device, how much energy goes into transmitting the data into the cloud, and how much energy is actually consumed in the cloud to process that you request? And I think that this is completely invisible to all of us, and that's where the crux of the problem lies. That's the opportunity for us to put intelligence everywhere. Now, we found a huge market in bringing intelligence to sensors. Let me give you two very tangible examples of how we do that. The first is that we're building intelligent smoke detectors. Imagine you're in a very large hotel in Las Vegas, like the Venetian. It's got 1,000 rooms. And if there's an emergency and everyone's got to evacuate the building, how do you know which rooms are occupied and which rooms are empty? You've got to be able to send fire services to the correct rooms. So what these intelligent smoke detectors do is that they use an infrared sensor to image the room. They can't take a picture of you. They can just recognize the heat signature of people in the room. And what we do with our neuromorphic AI is recognize that signature. So we can differentiate between the heat signature of a human, a coffee cup, a laptop which is running in the corner of the room, and we can very accurately count the number of people inside of the room, even if they're lying unconscious under a table, for instance. The true power of AI is reflected in these applications. You've got a tiny chip inside that device that is actually doing this recognition. On the complete other end of the spectrum is something which is going to revolutionize healthcare for everyone. And this is a use case which is very close to my heart. We developed a solution that allows something like your smartwatch to look at your ECG throughout the day, 24/7 for years at a time, to detect the earliest signs of heart disease, long before you become symptomatic. Very often you've just got one aberrant heartbeat, and we can spot that, and we can very accurately say, you're showing early signs of a disease long before you actually have any sort of complaints. The true power of taking ultra-low power AI and putting it into devices is exactly this. It changes the way devices serve us, at the end of the day, improving our quality of life. And that's the ultimate ambition for us.
So do you see this as a particularly good, and this is for you as well, Dennis, do you see this as a particularly good opportunity for Europe, where we have much more focus and concern about data privacy than the US or China?
Absolutely. I think that we've got a very healthy respect for privacy, for integrity, and I think it should be fundamental to how we design products. One of the applications that we're building is a fall sensor for bathrooms, and obviously you don't want to have a camera in your shower, but you still want to be able to detect when somebody falls. And you really have to be able to pack AI into the end device to do applications just like that. That does not mean that you cannot share your data with the cloud to have better models in the future. But the ability to control and give you that choice should be yours. Okay,
thanks. Dennis, to what extent do you see energy efficiency driving the market?
Yeah, absolutely. Very great question. So I think, on a fundamental level, what is the problem you have to solve? Like current architectures, they are essentially based on having like a set of software code that is in the memory, and then instructions read it to the processor, gets executed and written back. And you do that, like in the case of AI, billions and billions of time. And so most of the time and energy is actually wasted on data transfer rather than the computation itself. So that would be equivalent to having like a 16-hour commute for a 4-hour workday. Nobody in their right mind would do that. But this is exactly what we do on a large scale currently, like with digital architectures like NVIDIA GPUs. And this is why the brain is such a great template to design fundamental new chips, because in the brain not only is this bottleneck like orders of magnitude better, it doesn't even exist at all, because processor and memory are the same unit. This is what synapses and neurons are doing. And so that's why there is a radical problem that can be solved, and this is a great opportunity for Europe because we are very strong in research. However, we lack some different kind of skill set, and I'm going to come to that in a second. But on a more fundamental level, if you are able to have on-device inferencing, on-device training, that means you process the data exactly where it is created, right at the sensors. You can't be any more efficient than that. So compared to generating the raw data, transfer it to the cloud, which is energy efficient, inefficient in and of itself, and then process it there and then just have the smart data come out of the data center. No, I want to create the smart data locally, close to the source, and then maybe not forward the smart data to a data center if necessary or beneficial, but maybe I don't even have to because it can stay on my phone. And that's how you solve fundamentally the issue of the sustainability problem of AI. But in order for Europe to actually make progress on there, I think there are a couple of things that need to be happening. Because Silicon Valley is the place to be right now for a reason, and it doesn't have to do particularly in the first place anything with money. I think it's mindset. It's mindset of more people dare to take the bet on going out from research and spin it into a company and try to create products. It has to be people working for those early stage startups. I have the feeling in Europe we tend to look a little bit more, oh, I don't want to be like, take this high risk path of if the company goes down, is not successful, then my equity is not worth something. Where in the US, I would argue people are more like, okay, but if company is successful, I'm going to be incentivized a lot by the money that I'm going to get. And it's also the same like with investors, rather than just more and more looking into reasons why not to fund a potentially disruptive company. Take the bet you won't be successful for quite some investments, but there are going to be more investments like these trillion-dollar companies that Europe needs to have more. And I think that's like something that you need to work on. It's not just like pouring money into something to try to create a Europe Silicon Valley. This is not going to happen because the fundamental value proposition from what I see in the Silicon Valley is the mindset, and that's not just something that you get by throwing money on it.
Seth, I'd love for you to react to that.
Yeah, I mean, I agree with everything that you just said vis-a-vis Silicon Valley versus Europe. I think the potential for Europe is massive because the caliber of technical talent matches what we have in the US. Some of the best technical universities in the world are here. Some of the best PhDs pushing forward cutting-edge science are here. But the mindset of entrepreneurship is just not there. And I think a lot of it is cultural. I actually don't think it's not capital. It is a shift in mindset that's necessary. One, there's not enough audacity. Which is another way of saying there's too much pragmatism. And I know it sounds silly to say too much pragmatism, but startups and entrepreneurship is one of these really weird areas where pragmatism in the early days just hurts. It's not great. You need to have this incredibly audacious vision and just have this irrational confidence that you're going to achieve it, right? You know, Jeff Bezos, before he sold a single book online, when people were telling him he couldn't sell books, was already in his mind thinking, I'm going to sell stoves, and I'm going to sell cars, and I'm going to sell everything online. It's irrational. And in Europe, that kind of audacity is frowned on among your peer set, among investors. They don't like it. There's not enough risk-taking. There's a bit of a tall poppy syndrome. In Finland, they have a day when taxes are published because it's all public. And the day when the taxes become public is called the day of shame, because the newspapers go through the list and they find everyone that paid a huge amount of taxes and they put them up on the front page, and people kind of like wave their finger at them. And it's like, wait, what? You know, these people are literally paying for this beautiful socialist system that you have. But it's considered a bit impolite to sort of succeed too much above everyone else in Finland. And so the people who had a really good year financially are a bit embarrassed about it. And like, if that doesn't change, Europe will never have a robust tech ecosystem. The other thing that really needs to change is an acceptance of failure. This is probably the hardest one. You know, in the US, we are indoctrinated from youth. We're taught in grade school about Abraham Lincoln, who most people consider the greatest US president. He bankrupted several companies. He ran for office and lost several times before going on to become the greatest US president. And we're all taught this in grade school about how, oh, it's, you know, what really matters is that you just keep on trying. Failure doesn't matter. And so, like, how do you overcome that fear of failure in Europe? This is probably the hardest one. But yeah, I think the potential is there. We have a company creation program called 50/50, which we were talking about, which we've been running in the United States for 3 years. And we're bringing it first to the UK, maybe next to broader Europe, because we have so much belief that these things can be changed, and there's so much potential in Europe.
So, in terms of, technological opportunity, how do you view neuromorphic computing? And are you seeing similar startups in the Valley? And how does Europe stack up in that sector?
Yeah, I mean, I think it's very interesting. So I sort of wrote down 3 main predictions, and this touches on one. So I'm going to make some predictions by 2030, because 5 years away. So hopefully I don't look ridiculous in 5 years. But one of them is that as embedded AI takes off, energy efficiency and thermal management overtake raw speed as the key metric. Right? When we're pushing more compute into devices, into things like humanoid robots, things like energy management and thermal management will matter even more than raw speed. So that's number one, and neuromorphic for sure helps there. 2 is that by 2030, it will be as silly to not have an incredibly powerful AI running locally on your device as it is to not have a smartphone. And also that AI, it will feel like it knows you better than your family. Which will only be possible because you can just share everything with it and know that that data is not leaving anywhere. I guess for some people saying it will know you better than your family is not very meaningful, but for some it is. And third, I think we'll move from a world that is just completely and totally dominated by NVIDIA into a multipolar hardware world where at least 5 different chip architectures are taking 10 to 20% of AI workload shares. So this, might be GPUs, TPUs, NPUs, analog, neuromorphic. And by the way, I think this will happen, and also NVIDIA's market cap might triple. Because the one thing I disagree with you on, you said that pushing to the edge will solve the sustainability crisis. With AI, I don't think it will. It's true that it will take a lot of computation that would have been performed in a high energy setting and push it to a low energy setting. But all of that freed up resource will just be used for cutting edge compute, right? So if you're talking about models that are pushing state of the art in mathematics, or pushing the state of the art in physics, or pushing state of the art in biology, those are still going to need to be run on these sort of massive data centers. And so I think literally every iota of compute that's freed up by pushing to the edge will be taken by the cutting edge applications, which are still going to require being run on data centers.
Thanks. Now, assuming those predictions are true, how is this going to impact different sectors? And Sumeet, I'll ask you, I know you're working, for example, with the automotive industry. How is moving the intelligence to the edge going to change things in that sector and others?
So I really liked your predictions, and I think that I agree with them, especially the first one. We're at a very interesting time in the computing landscape. If you imagine 1971, when Intel was creating the 4004, prior to that chip being created, microprocessors were basically these large boards with discrete components on them. And then the company came along, and then they came up with this new component that we call the microprocessor, which is everywhere. We're now witnessing something just like that, with all these different kinds of AI making into new kinds of chips. We're witnessing the creation of a new component. We don't know what we're going to call it. We don't know what exactly it's going to do. But fundamentally, it's going to change how systems are built. I think that future sensing systems will become smaller, cheaper, much smarter, and they'll be able to serve you so much better. From an automotive context, that will lead to cars that are safer, that can intuitively understand what you want, what your needs are, and how the vehicle should adapt itself. And all of that will come at an energy cost which is so negligible that you don't even notice that you've got all this intelligence around you.
When we spoke earlier, you mentioned one application in particular that I thought was interesting, this idea that if you had sensors in the brakes of your car, they would be able to anticipate before you, as a human, could even react if you were going to hit something and actually put the brakes on. I thought that was really interesting.
Absolutely. I think that you're already seeing a lot of AI making it into vehicles because safety is such a big requirement in these use cases. And the jury's still out in the automotive world about where you do AI. Do you do it in the central computer, or do you do some in each sensor? And we think that it's a combination of the two. It's not one or the other. You've got to have central compute, which is very powerful, but you've also got to have sensors that can make sense of the data where it's captured. So in the event that there's a failure somewhere in the vehicle, it can at least pull off, off the road, park itself safely, limp back home, and that really requires this sort of distributed intelligence.
And people often make the analogy to humans, and they say, oh, but humans have one big brain and it does all the compute. But that's actually not true at all. There is computation happening throughout the human body. Different organs compute. The immune system runs computations locally. Cells, in many ways, are running computations locally. And so we have literally millions of points running computation locally throughout the body. And yes, we have a sort of central GPU-type unit that organizes it all, but it's entirely possible that the future of automotive, of robotics, of all appliances looks more like the human body than how we sort of currently build electronics.
And also maybe to add to that, it's also the interchange of information between humans, which makes it possible so that when we have a conversation that 1 + 1 equals more than 2, this is also interesting when intelligent sensors and systems can talk to one another, even though they might not belong to a particular system. And like car-to-car communication in the context of cars. But I see that happening like everywhere, and I think this is an exciting time too.
Thanks. Okay, I'm going to now start, moving into some of the questions from the audience. The first one is from Tim. What role will edge AI, cybersecurity play in future? And are current cybersecurity approaches, homomorphic encryption, temper-resistant hardware, enough? Who wants to take that?
I can start. I think that attacks on chips, attacks on systems are continuously becoming more complex, more sophisticated, and harder to detect. And I think the first place we'll see neuromorphic or general AI approaches take a hold is in chips that can detect if their integrity is being compromised. Let me give you an example. When you're building a very complex system on chip, you're very often licensing IP from a number of vendors. You're putting in blocks that you're just buying from other people. You don't know what's inside of it. You've got a data sheet which says that the component does something, but there could be a little Trojan horse sitting somewhere inside that you just cannot spot. And if you've got AI on the chip that is intelligently monitoring the interconnect and how data is moving around, you can very quickly identify patterns that don't make sense. And you can use that kind of to flag any suspicious activity that happens inside of the chip. This is something that we don't often have too much visibility about as users of these chips. But as a provider of chips, this is something that worries us quite a bit.
Okay.
Yeah, maybe I'm not too familiar with the concept of homomorphic encryption, but from my understanding, that means even though you can have all the operations of addition, multiplication, the stuff that you do in AI models, you can do that on encrypted data. So you would never need the raw data. They are all encrypted, but you can have all these operations on the encrypted data, and it still does everything it's supposed to be, and then you can be transferred back, and you can decrypt the data locally, and you will still have the information with the hope that nobody basically was able to decrypt it before you. I think another thing is going to be interesting. Attacks on digital chips are easier because you have these clocked signals. You actually can very easily reconstruct what is about to happening. However, like analog chips, which is something that GEMESYS is working on, and I think you too, to decode what is happening on the chip by measuring external signals, which is what you do in an attack, is harder to reconstruct in an analog chip compared to a digital chip, which might be an additional benefit apart from the energy efficiency as well. That would be my answer to the question.
Okay, thanks. So next question from Anonymous is, how do you plan to handle the fact that standard low-cost chips already deployed to real-world solutions can do edge AI with comparable power to yours?
Let me take that. We compare ourselves to many of these standard chips which our customers use, and pretty much across the board on any application that you're looking to build, we outperform these chips by a factor of 50 to 100x on power, on latency, as well as on the ability to pack functionality which has not been achievable to date into these devices. Microcontrollers today are able to do a lot, that's true, but we're only scratching the surface in terms of the AI that we're actually deploying into endpoint devices. The next generation architectures which will make their way into the market will unlock applications which are simply mind-boggling, and you need these new architectures for those.
Did you want to say something?
Yeah, I mean, all I know is that for all those chips that I want in those humanoid robots, we definitely can't do it on a 5 to 20 watt power budget yet.
Okay. The next question is, what is the main challenge in developing more efficient AI chips at the moment?
Well, I mean, there are multiple levels where you can attack this. So you can have like all the standard operations that you have and argue like a GPU is like a quite general architecture. You can narrow it down. I mean, this is the efficiency that you get is specialization versus generalization. That's like one of the things. That's like, I would argue that's like low innovation because it basically builds on everything that there is. The fundamental concept of the architecture was derived at a time that nobody was talking about AI, and so it comes to no surprise that it's not a good fit for these tasks. And depending on how innovative you want to get, like going completely analog, being very close to the brain is something that comes with a special set of challenges because in the end you have to be able to scale it up properly with all the variations when you produce a chip. It's like variations across the devices on the chip and with noise, and to make it robust working. This is like if you really want to have a fundamental new architecture, you are not building on the decades of innovation that digital architectures already had. And so that's probably like the biggest challenge that there is, that you're not standing on the shoulder of giants, but you have to do the hard part yourself.
I want to add something very quick to that, and it kind of links to what Seth said pretty early about ambition. What would, from a product perspective, what would you do if power were not a problem for AI? What would you build inside of your devices? That's exactly the issue that we get confronted with when we're talking to customers, because the kind of benefits that we put on the table are simply unprecedented. I'll give you an example. We applied our solutions to do human presence detection in video doorbells, and our solution increases the battery life of the device from 3 weeks between recharges to 1.5 years between recharges. So you have your doorbell, you plug it in, you charge it up, you put it on the wall, and you forget about it for a few years. That's not a user experience that anybody aims to deliver to customers today, because the technology to do that simply doesn't exist. So when we go out with very new capabilities into the market, it's mind-boggling. It's very hard to understand what I can do with this. Educating the market and connecting the problems with the solutions that are available is actually where much of the effort goes into today.
I mean, if I could solve one thing, it would probably be the ability to build chips in 3 dimensions.
Wow. Okay. The next question goes to the heart of, I guess, Europe's competitivity. What's the role of research institutions like the University of Delft, for Sumeet, in the AI chip revolution, and what should they be doing to speed it up?
I think as Europe, we've got to be much more ambitious. We have great research going on in our universities. We target the toughest problems in the world with our research, but somehow when we get done with these projects, we kind of forget about the IP that we have developed. We've got to be ambitious about going out and building world-class companies with that. We shouldn't be shy about having a global impact, but we also shouldn't be shy about making money off of these sort of innovations. And I think that that's where we've got to do a lot better. Go into universities, make it simple to spin companies off without getting into these protracted discussions about the structuring of the company. Make it very simple, and you'll see a flood of innovations coming out into the market.
Yeah, absolutely, I agree. And also, like, apart from the mindset thing that I mentioned earlier, it also sometimes with these research institutions, it's about the conditions for the founders to spin that out. Some of these research institutes want to take like a 30% stake in the company, which, as an investor, probably would agree, this is something like 30% stake from someone who didn't give any money and is also not operatively active in the company. It's just something that probably is a stillbirth from the beginning. And so to have in mind that it doesn't make sense to have 30% of something that's either small or non-existent, and to make it, possible for the founders to start something that could have like a very promising future.
I mean, European academic research institutes are world-class engines of innovation. But just because you publish something in a paper does not mean it in any way impacts the world. There's a very small number of things for which that's true. If you figure out that doctors should wash their hands a certain way before surgery, yeah, probably you just publish it and word will get out and they'll wash their hands differently. But for like 98% of stuff, someone needs to take the science and turn it into a product or service and scale it to the world for there to be any impact. And so first, as was mentioned, there needs to be a realization that the truest manifestation of the science might be starting a company. It's not that you're selling out to get rich. It is that you're actually working to make sure that your science sees the light of day. 2, we need to fix tech transfer. It's like 10 years behind the US. Sometimes these universities also ask for board seats, which means now a university bureaucrat who's probably really good at running university is literally going to be in charge of the company, which is a non-starter, for instance, for any American investor. And then we need to fix the general way companies spin out in Europe. There's basically been 3 phases to this. Phase 1 was a VC or company would go to a TTO, which is a tech transfer office. That's the part of the university that owns the IP. And they'd say, hey, what IP do you have for me today? And they'd say, ooh, I like that IP. I'm going to license that IP. And it would almost certainly go nowhere because none of the people involved in the creation of the IP were involved in that company. So that gave way to phase 2, where instead of going to the tech transfer office, VCs would go to a PI or professor and say, hey, if you have a technology that could start a company, let us know, and we'll start a company with you. And the PI would become an academic or scientific co-founder. They'd get some equity, and the VC would start the company. And that works a little bit better, but still not great, because the company is probably that professor's like 5th priority in life, and they're probably absent-minded anyway. And so what we're hoping Europe moves forward with is what we call phase 3, which is power to the PhDs. Go directly to the PhDs and postdocs that had the idea, that did 90% of the work, that wrote 90% of the paper, and say, listen, if you think the best way of manifesting the impact of your technology is to start a company, you can do it, and you can be the CEO. Because it turns out it's much easier to teach a deeply innovative person how to business than it is to teach someone who knows how to business how to be deeply innovative. And so we think that PhDs and postdocs, A, need to seriously start considering startups, and then the ecosystem needs to empower them, and it needs to say, listen, you don't know what you need to know right now to be a great CEO, but neither has any first-time founder in the history of technology, including Jeff Bezos and Mark Zuckerberg and Larry Page and Sergey Brin and Steve Jobs and all of them. And so we believe in you. We're going to support you in becoming world-class CEOs. If Europe does that, things will be amazing.
Well, I think that we're almost out of time, but I do want to mention that, as someone who has been observing the European tech scene now for 30-some years, that, we are making progress. And Sumeet, your company is a perfect example of that. A spin out of Delft, you've raised already, just in your seed in first round, I think over 25 million. So we're getting there. We're making progress. And, I think that the message from this panel is really that there is a lot of opportunity. NVIDIA does not have the lock on the AI chip market, that things are evolving, and that there's plenty of opportunity here, not just for entrepreneurs in Silicon Valley, but also here in Europe. So with that, I'd like to thank the audience and thank everyone on our panel. Thank you very much.